And I think that's part of the problem with disclosure. I don't think they know what to disclose. I don't think they really know. I think they know bits and pieces. I think they know a few little things, but they don't really know what the big picture is. And so disclosure doesn't really work because we're going to have so many questions that they won't be able to answer. So what's the point? I think that's the real problem. They might have a craft or something, but they probably don't know how most of it works. And they probably don't know. Even if you have a craft and bodies, you still don't know where they're from, and you don't know what they're doing here, and you don't know what their intentions are. See, so the big questions that you really need to know, you aren't going to have any info on. I think that we're I think that the best thing to do is to have everybody work together on this problem and try to figure it out. Yeah, I found that only about 22% of spacefaring civilizations were capable of interstellar travel. 1 out of 5 of them could make it to another star system. Um, and so but then finding Earth is a much lower probability. So in all, if you have a spacefaring civilization somewhere in the galaxy, the chance that they could find Earth is 0.00009%. What would you need to do to be able to find Earth? And or what would your qualities be like? And so one of the surprising things that I found, first, you don't have to go faster than the speed of light. You don't even need to go more than 30% the speed of light. 30% the speed of light makes it possible. And that's something we might be able to pull off at this point if we tried. Um, so So what I did find though is that they have on average, after they basically they're colonizing areas of the galaxy, so on average the radius of their domain is something like 500 light years on average. So they go a long distance. And the average distance to Earth from their home world is on the order of about 500 light years. So the uncertainty of that is actually quite high. It's 500 plus or minus 400 light years. So you don't really, that's an average. Um, but what I found was really the most shocking was that then what is the average, how long, if you find somebody is here now, you can then calculate when they first discovered Earth on average. And the answer on average comes out to be about 1 million years ago. So so if there are non-humans here on Earth that came from somewhere else, colonizing their galaxy in this way, they probably found Earth 1 million years ago, which means they've been here the whole time, which which is in agreement with sightings. I mean, you have sightings going back to the Roman times. There are ancient Chinese, Japanese sightings. There are and those are of discs, very similar, or flying earthenware or flying umbrellas if you're in Japan.
Why you do if I own something, why I hyped? Like, it doesn't settle with me.
Those are all great questions, and it gets to be hard because now you have to start to worry about intention.
This is second time. It's almost 1 year now, the recording, so time flies.
Oh, that's right. Yes. No, thank you so much for having me again. It's good to see you.
Okay, so first of all, I want to say that congratulations for the new 2 papers. I think it's, we have to recording this next second time, but I was trying to say this is a really a big deal for the UFO community to see real publication. And most importantly, that in academia, we discussed this time that a bit of pushback and this is not real science, there's no literature. So I think that's the reason, I think that's why these 2 papers and others very important for the UFO scientific research. Yeah.
Oh, thank you so much. Yeah, no, we're very excited about them. The first paper that was published was the one first authored by Matthew Shadagas, my colleague at UAlbany, and it basically summarizes our first data collection mission to Catalina Island, that you can see featured in the documentary A Terror in the Sky. Um, that's a documentary that shows all the excitement of that we had collecting the data. If you want to know what we actually found and learned, you can read the paper, and the scientific paper has all of the information, which is very good. There was in the documentary, you'll see that the first object that we saw was a bright light. The Catalina team saw a bright light um, moving, and then after some time it disappeared, and yeah, there was a lot of excitement, and it turned out, this is a spoiler for anybody who hasn't seen the documentary. um, it was We identified it, actually Matthew Shadaga's identified it. It was the International Space Station, and we didn't realize that at first because the app we were using didn't take into account daylight savings time, so it was off by an hour. So that's the really when you actually go to try to collect data, what you usually learn, especially the first time, is what not to do. Um, and you learn how to do it properly the first few times out. And so that's really what we learned that first trip. But it but Matthew was able to verify that it was the International Space Station because he took the number of pixels that it took up on the iPhone camera that was filming it, and calculated, given the known height to the space station, calculated how big the space station would be based on the pixels. And I think he came out to like 110 feet across, and I think he was off by a foot. So he was able to measure the size of the space station with the iPhone camera, with a precision of a foot, something close to that. So it was quite nice. Um,
Yeah. So I think my biggest interest in this paper about the sensors that I think that what I really appreciate about your work that you get in details like the data. You need the data as much as possible. I think that's the saying I think we need the most, the more data and the sensor. You spoke about the sensors, and also I think I have to highlight that you have been doing this with your lab in Albany and UBX. So that's the only I think resources you have access to. And if I understood, Avilop had their own the Galileo project. They have their own also sensors. It seems, yeah, we will dive in that. But I think before going to these details and the resources and how you managed to get all that, what was the reaction of your colleagues when the papers are published? Did you get any reaction from naysayers?
oh, there's a lot of excitement in the UFO community. The second paper is the one I first authored, and it's basically a review paper that describes has what's been done to study UFOs or UAP scientifically for the last 80-90 years. And um, and that paper it started out as a well, when we first submitted the UAPX paper, when Matthew Shadaga submitted this, um, one of the comments back from the editor after the review was that there should really be a section of that paper discussing the scientific study of UAPs. And so Matthew was busy fixing up other parts of the paper, and so he calls me up and he says, "Kevin, can you please write a section on the history of the scientific study of UAPs?" So that weekend I start writing, and I just was when you really get into this, you really go into autopilot, and collected all the information I could, and I start trying to put it together in a paper or into a section, just a few paragraphs, and I realized there is far too much information here for me to summarize. I don't know how to begin summarizing this. So so I just typed it all up. I just wrote it all up. Let's get it on paper, and then I can cut it down to size, and we can cram it into our UAPX paper. And I sent it to Matthew. By the time I sent it to Matthew, it was 10 pages long. And I thought, yeah, this isn't gonna work. He wants a section, not 10 pages. So so Matthew actually suggested, he goes, "Why don't we ask the editor if he would be interested in us submitting a second paper, which is more of a review paper?" and the editor liked the idea. So I set off to write this review paper. And as I collected more and more information, I realized there has really been a lot of work done to study UAPs, and it was shocking to me because as an academic who had been taught, by other academics for my whole career that UFOs are nonsense, and I've heard, and we've all heard, UFOs are nonsense. Scientists don't study them. Scientists have never studied them. Scientists don't see them. Astronomers don't see them. They don't ever see them. You hear all these claims, and none of them are true. I'm finding out by digging into this. So, so then I started redesigning the paper. So the paper is really laid out so that it basically dispels all of these false notions that academics have about UAPs. Um, The problem is that academics have not studied them, and then they stand up and voice their opinion. But as Stanton Friedman once put it, who was a physicist, but also a ufologist, as he puts it, that before you open your mouth on a topic, a professional ought to do their homework. And these academics who are talking about UAPs have not done their homework. It took me about a year to write that paper. So that was a year of homework I did, and I learned a whole lot about UAPs. And as the paper grew, I realized I'm going to need some more assistance. I need some more expertise. So I started calling on my other colleagues around the world and saying, hey, it started out first. I wanted to summarize the current efforts to study UAPs. So you have people on the Galileo project, UAPX, that's us. The Galileo project, I contacted some of them. I talked to Hakan Kayal and IFIX in Germany. I talked to Beatrix Villarroel and Vasco in Sweden, and and Luc Denis and Baptiste Friescourt and Michael Valiant and others in France, and wanted them to summarize what they've been doing currently. Um, and then the more that I did this, the bigger the author list got. And after I worked through summarizing so the paper actually doesn't start in 1947 like people tend to believe. People tend to believe that the whole UFO thing started in 1947. That's totally not true. Um, UFOs have been seen throughout antiquity. I mean, all the way back Roman times. There are sightings. Now we don't start there because this is a paper on the scientific study of UAPs. So we really start with the Swedish government in the 1930s. Is where we start, and we did that on purpose because we wanted to dispel the notion that this is a purely American phenomenon, because it's not, and it started all in 1947, which it didn't. I mean, 1947 was an interesting year. Some interesting things happened during that 2-week period, and we discussed that to some degree. So the paper, when it was finally finished, was in the original format was 194 pages long, and had over 500 references, and we have 32 authors, or maybe 34, around a little more than 30 authors. So, and the authors are from around the world, and so it highlights that we scientists are communicating with each other. We're working together globally to try to solve this problem, and I find that all very exciting. So it's really quite quite an exciting time. Any academics who want to study up on the topic, this is a great paper to start with. First, read this paper. I mean, the way you learn about a topic is you do what we do with our students. You give them a couple of the important papers in the field, and you tell them, go read these papers. And then they come back and they, 2 weeks later or whatever, and they say, oh, I've read these papers. And I said, all right, now go back and read all of the references to those those papers, right? And they go back and they read the references. That's what we do with our students to educate our students. Um, are the professionals any different? They shouldn't be. We should be doing this to ourselves. And when you study something now, Now, you don't necessarily have to go read all of the references to this review paper, but some of them would be helpful. Yeah.
Yeah, and I think I should before going again the detail. I think in the second paper, and sometimes the result is not, yeah, positive as we expected. Like as you say, seen something or prove something. So I think that was a bit of defining the nature of publication academia. That you don't have always to get a positive result for the second paper, and I really appreciate the sharing that. But I'm not sure, how do you see the next step for publication in the youth community? Do you anticipate more people will, yeah, put more money in funding? Because I think it comes down to the setup. That's what I need to understand for you, that the resources, the location selection, the sensor selections, and the quality of the data, all of that, and how you manage to, because it seems every project, Galileo project, they have their own setup. And so, yeah, if you can tell me about that as well. Yeah.
Yeah. No, so a lot of the work that's being done is being done by multiple groups at this time. And they're working rather independently. I mean, in science, people don't work independently. We collaborate with each other, we talk to each other, we share information, and that's one thing that I've found. Being a scientist, that's what I found makes science great. Science doesn't have boundaries the way that um, other human activities do. Science is very unifying. Um, because we're all trying to find out the truth, right? And there's one truth, and we find it out through using data. So you have to go collect data, and you have to study the data. You share the data, and so we're all constrained by the same things. So we're all heading to the same goal. So it's a very unifying process. So, yeah, so with the different groups having written about, what they're doing, some of the descriptions in that paper even have descriptions of the equipment they're using in some cases, or have references to publications that have descriptions of their equipment. So, um, that information is now being shared across groups, and we're constantly talking about things like this. Oh, this is a great camera to use. No, that's a really crummy camera. Don't use those cameras. Those are horrible because of this and this and this. They have these artifacts. These are much faster speeds and have higher quality. Or I recently got a diffraction grating that I can use on my Canon R6 camera, and I've been playing with that and testing it and trying to see if we can actually get spectra. Can we record spectra for UAP? And that would be a very important thing
Mhm.
to do.
Maybe first thing, can you tell me about the location? That, like in the paper, you mentioned with your co-authors the Catalina Island. So can you tell us, the rest of the group, first how you choose the spot that you want to go for, and then according to the resources that you have in your lab and UBX, I think that the choice of the sensor available to you and how you arrange the setup. And can you go through that, and what is the limitation? Like initial, like Rust was just learning about how this process go, because I think there's a frustration in the UFO community. That's the blurry images. So if we understand that, at least from the other scientists, give us an idea how to get there with at least collecting high fidelity data as much as possible.
Yeah, no, selecting location is not quite an easy thing to do. In getting data on UAP and UFOs, it's not easy because you have to go find one, right? You have to go find one, or get and sit there with your equipment and wait until one shows up, right? So they're not horribly common, and so that's a hard thing to do. So let me first describe how we picked our location to observe the Catalina Channel. So UAPX was actually founded by Kevin Day and Gary Voorhees, who were both involved with the Nimitz 2004 encounter. So Kevin Day was manning the radar and was monitoring the tic tacs on radar and he's the one who actually sent the coordinates to Commander Fravor, who first flew to the location to see the tic tacs. So Kevin Day and Gary Voorhees founded UAPX, and their goal was to they wanted to find out what actually happened. They wanted to find out what are these Tic Tacs, what actually is going on with them. Can we get more images of them? Can we get photographs? Can we get data? That's what they wanted to do. So during that encounter, they were the Tic Tacs were appearing on into November 2004. They were appearing on Kevin Day's radar at about 80,000 feet, very high up, just south of the Catalina Islands. So it was right in that area, and that's basically where they were first appearing on his radar. And so we wanted to go back to that location to monitor that area. And when we started researching it, we found that that whole area is what you call a hot spot. There's many, sightings going back, decades related to the Catalina Channel. So, and in fact, one of the cases that we talk about in that I talk about in the paper when I talk about there's a 2 week period of in 1947, um, pretty much starting with Kenneth Arnold's sighting near Mount Rainier in Washington. Um, there are the number of UFO sightings in the US goes from about 6 or 7 per day. It's basically what we in science what you call a Poisson process. So it's a 6 or 7 per day. Um, and then after Kenneth Arnold's sighting, or just starting around that time, it ramps up to about, I think it was about 250 per day. The number of sightings skyrockets very quickly and then drops again over a 2 week period. And and if you look at the variance of the sightings before that 2 week period and the size of that signal, it's a what we would call a 21 sigma difference. Um, 5 or 6 sigma is extremely significant, and those are basically the limits that are used in particle physics to verify things like the Higgs boson, right? But this was a 21 sigma difference. Huge, 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 huge. Something really incredible happened that 2 week period in July of 1947. Now you can argue it was sociological, and that I would think, well, yeah, we need to, and we didn't. It would need to be studied to be absolutely certain. But when you look at the sightings weren't all like Kenneth Arnold sightings. They were all quite different, and many were seen um, by professional airline pilots. They had a propeller-shaped object was following one passenger jet. Right. There were landings there across landings in several locations in the West with multiple witnesses, 20 witnesses, 60 witnesses, including police. Um, and that's actually when the Roswell crash happened, right? The purported Roswell crash. And then about a week later is the San Augustine Plains crash, which is about 100 miles away from Roswell. And they're often conflated. Um, people who, skeptics who don't really study the topic and just complain about it, often say, well, the witnesses don't even agree with what they saw. Well, sometimes those witnesses were from two different crashes. There was a lot happened those 2 weeks. It's pretty spectacular. But the point was, running off into left field about that 2 week period because it's quite exciting. One of the sightings that had occurred was from several Marines were on Catalina Island, and they saw some discs fly over, and one of them, young, actually got a photograph of one of the discs. So so it's not just hysteria when people are getting photographs, right? So you can't just say that that 21 sigma spike is just hysteria. It's not that simple. Um, and so so it's so we learned that the Catalina area was is important, and that's basically what we decided to set up our equipment for our first measurements.
So the next step about the selection of the sensors, because I think in the paper I spoke about the sensor selection and what you're exactly looking for. And I appreciate the fact that you mentioned about there's different things you measure, the UV and magnetic. there's different variation. If we can deep dive in that to understand, once you try to set up that setup that you said triangulation, make it a triangular shape, and also can you speak about this configuration, how you set up this sensing to capture the data? If yeah, if anyone not familiar with that, can you tell us about the scientific procedure for that?
Right. One of the people want to see photographs, right? So we would like to get photographs of these things. So we have regular cameras, high quality cameras that are watching. Um, you often hear people complaining, "Oh, with all the cell phones, why are there never any photographs?" Well, the cell phone cameras are really not that great. Ask a real photographer. They so we actually had professional cameras on site to get good imagery. Um, so you want to get visual imagery. You also want to be able to see at night. So infrared imagery is helpful there. You can see thermal temperature differences with infrared imagery. Warm things give off infrared light, so the background gives off infrared light at different wavelengths of infrared light at different temperatures. Um, and so not only can you get a thermal image of the object, but by looking at those frequencies of light, you can actually tell what temperature the object is, which is really important because if you've got something with a jet engine on it, that jet exhaust is really hot, and that's going to show up in the video or the imagery. And that's actually what the Navy was using. They were using FLIR cameras. Those are forward-looking infrared cameras. And why are they fuzzy? Well, because it's an infrared camera, you're picking up temperature differences. You're not actually getting a visual image of the object. Um, but the Navy videos of the Tic Tac, when that Tic Tac accelerates off to the left, you don't see a jet trail or anything like that. There's no evidence of any kind of propulsion coming off of that thing, which you can see very easily when you get an infrared image of a jet. And and very often we found that that's true for the Navy videos. We also have an infrared video of a UAP following a passenger jet, and those UAPs are cold. They're almost always cold, 60 degrees below 0 Fahrenheit. Um, Whereas you can have a jet engine, a jet airplane, passenger jet flying, that thing is rather warm, even if it's coming from high altitude. Our engines and our equipment always run hot. They produce waste heat, but these things are often cold, which is very strange. Go Fast, one of the other Navy videos, also infrared image. Um, it's the video's called Go Fast because it looks like it's going fast. I don't think anybody ever claimed that the object was fast. And so a lot of skeptics tried, analyzed and said it's not going fast at all. Well, no, it's not actually. A lot of it's just perspective, but no one actually claimed it was going fast. The video is just referred to as go fast. Um, but what's amazing about it is it's basically as looks like a spherical object. It's hard to tell how big it is because we don't have good scale, and you can't. You need multiple cameras to accurately measure distance and size. Um, but the object's cold, very cold, much colder than the sea surface, which is why it was bright white compared to a dark sea surface. And so we want infrared imagery. That's very helpful.
And by the way, your conviction is this is something physical phenomena so far, based on still for a lot of data you need to, but do you lean it's physical phenomena or something advanced, a little bit of technology?
It's not clear, and there are different types of UAPs. I think that's one thing that makes this topic difficult and has caused a lot of trouble in the past is that we aren't UAPs aren't just one thing. They're multiple things. And I mean, nobody a lot of them we already know are misidentifications, right? Um, and so it's probably, at least up to 90% of them are misidentifications. And so we're interested in that several percent. Those are the interesting cases. but they can be very different. You can have metallic discs. You can have metallic spheres. You can have glowing spheres that look like balls of plasma or ball lightning. And it's not quite clear what those things are. And nobody would ever claim that they're all alien spacecraft. I mean, no, you can't possibly believe that. We don't know what these things are, and that's what makes them interesting. That's why we're studying them.
Hmm. But let me ask you this quick question for going again for the what exactly looking for in this data. The recent hearing, I don't know if you follow the recent hearings. It was a couple of few days ago. Did you hear the Congress hearing on the UFO? That was a couple of days ago.
Not, I didn't get to hear that. Not yet. No.
Yeah, but anyway, I heard to it, and it just again, the question I'm struggling with if they already have evidence for advanced tech, and the as Lowell Alexander say that yeah, there's people, but they are not, I think, okay with disclosing these things, as far as I understood. So did you have any like you understood the team backlash or because if there's clear cut evidence and for the government that there is not yeah there's advanced check but we don't want to disclose that for security national security reason and whatever so how do you reconcile these two factors that you're trying to chase something and at the same time it seems there's allegedly clear evidence there is advanced tech beyond the human understanding.
Well, some UAP really do appear to be highly advanced craft. That really does appear to be the case. There are landings. There is physical evidence from the landings. There are imprints in the soil where they touch down. There's branches broken when they take off through trees. There's chemical evidence, and we talk about that in our paper as well. Um, they sometimes leave chemical traces on the ground that have been analyzed and studied. Phyllis Budinger, a chemist, has done a lot of that work, and we added a whole section to the paper on physical evidence. One thing that I didn't appreciate until I wrote that paper was that there have been collisions with UAPs and cars. Two cases. One of them was a deputy sheriff in Minnesota, and he saw a bright light, glowing down the highway, and he went to go check it out and drove toward it, and the thing raced toward his car and broke his windshield, damage to the car. He ended up going off the road with it, and that car is now in a museum in northern Minnesota, where you can actually go see the physical car and see the damage that the collision with the UAP did to it. Not a single, not a not any to improve.
There's some images you included in the paper some images about this crash.
Yeah, we had some images about the damage to the car. Yeah.
Yeah, and maybe the quick question, how yeah, I think, or maybe at least me, that how you validate the accuracy of this account that this was actually the scratches and the windshield.
I mean, it's an account. I mean, what do you do? They at some point you have to just take what information you can get and decide how reasonable it is. You know, the was the deputy sheriff drunk driving and had a hallucination and drove off the road, or is he telling the truth? I think he's telling the truth. He described what happened. Um, and his description of a glowing ball object is not that different from what other people describe. Um, Now, more interestingly, there's a case in Michigan where a woman was driving with her family, and there was a basketball sized glowing orb that flew at her car again and actually hit her roof and skidded along her roof and actually left chemical traces. And those chemicals have been analyzed. It turned out it was magnesium. So you don't have magnesium basketballs flying around in Michigan. That just doesn't happen. So this isn't there's this assuming there's a prosaic explanation here is really going to be difficult.
From the physics, you say that there's bit malfunction for the system and this kind of thing. So from physics explanation, what exactly happening? Like if you have to deter something or make something malfunction. So what is happening there from your understanding?
It's not clear what happened. I mean, I'm not sure why the thing flew out of her car in the first place, and it's not, are these, we don't, I don't think we don't have enough information to know what these things are yet. Um, was it intelligently controlled or dumbly controlled? I don't know. Was it just a physical thing that was randomly moving around? I don't know. Yeah, and that's going to be difficult to determine without more data. But there are some of these objects that appear to be craft with 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 great capabilities. There have been cases where accelerations and speeds and accelerations have been measured with radar, and in fact, rocketry pioneer Hermann Oberth, he was mentor to Werner von Braun, gave a lecture on UFOs back in 1954. This is 1954. This is 70 years ago. Gave a lecture on UFOs where he said that he had personally seen over 50 radar measurements of UFO speeds and that they could get to speeds of 19 kilometers a second. That's what he said in his 1954 talk. 19 kilometers a second is very fast. You're looking at something about 40,000 miles an hour for Americans, um, which is like what, Mach 60 or something. That was 1954 that they knew this. Over 50 radar measurements. So it has been known for 70 years that some of these things are some kind of advanced technology. We've known this for 70 years. The rest of us, the rest of society is really just playing catch up at this point. And our governments, not just the American government, but other governments have data and have information, and they've studied these things, and they're not talking. So the situation's very strange. Yeah.
I want to come to this again, but I think I want to jump again for the data. The quality of the data once you get it. First of all, what you're looking at this data, like to validate, oh, this is maybe good information here or not, and how you decide, like what exactly you're looking for. Because you look in the paper, the UV, for example, what are you looking for, kind of data. So, and how you arrange that to get the data you think could be helpful.
Yeah, well, we're looking to collect our own data. Um, it's very, very hard to rely on data from other people, especially the military. Um, with the military cases, you don't know what equipment they're using to do the recordings. So you don't know that you don't know that the equipment was properly used. You don't know first. You don't know what it was. You don't know whether the equipment was properly calibrated in the first place. You don't know if it's properly used. You don't because you don't know what the equipment is. You don't know what its failure modes are, or what kind of uncertainties you have in the equipment. Which so scientifically, it's useless. I mean, literally useless scientifically, and which is why we have our own equipment. We spend probably most of our effort so far has been spent characterizing our own equipment. We we try it out in many cases. We look for failure modes. Um, what does it look like when we put a fly on our camera lens? What does that look like? Try different shapes of flies or sizes of flies. What does it look when you have a water droplet on your camera lens and it evaporates? We've studied all of that, and you have to do that so that you understand your equipment, so that you can understand when you do see something strange, you can identify what it is and rule out what it isn't. And that's very important to do.
Let me ask you, during this scientific like journey to get this paper, the moments may be challenging or maybe surprising for you and the team, because yeah, you trade something, it's uncertain, you don't know what you catch in the sky. But do you have this moment, like in as a scientist, just like, yeah, giving up in the field is like, how much you have to wait, and because you say you're trying to trace something that's not there and hoping to find something.
Yeah, exactly. Yeah, you put your equipment there, you wait and wait and wait and wait, and then see the space station and get thrown by it, and then realize it's the space station, or or an airplane or a paraglider or whatever it happens to be. An insect flies past your lens. We've had all those cases and we've identified them. But it takes one of the difficulties is it takes time to identify these things. It takes time to work through the data, literally years. I mean, we've been working on some of that data for over 2 years now, and still trying to understand some aspects of it. So data analysis is not a quick thing to do. It's not fast. It's not exciting. It does not make for a good TV show at all. Nobody wants to watch a scientist analyzing data on TV. It's a lot of, sitting still and being quiet and thinking, and doing calculations or running computer programs that you've written to analyze it. Yeah, it's hard work.
Yeah, and what do you think maybe a missing piece of the puzzle? Because it seemed this whatever the physical, if it's physical or advanced tech or whatever, it seemed that it happened all of a sudden or appear at certain situation unexpected. So do you think chasing it? I'm not sure. I'm just speculating. Do you think whatever that's the thing, it's a physical phenomena or advanced tech, aware that they're being recorded and they don't want to be recorded with it? I'm just assuming. Do you think there's possibility for?
Oh, that's very possible. That's very possible, and that's a big problem. Um, as scientists, we usually study things that are not intelligent. So you study stars. Stars don't care if you're looking at them or not, and and they don't change your behavior when you're looking at them. So that's pretty straightforward. But if you're trying to study something that's intelligent, then that causes a whole other set of problems because the state of the object that you're studying is important and you don't know what that state is, and there's no way to know that state because you don't know its intent, you don't know what it's doing, we don't even know what it is yet in some cases. And so if the object is trying to be evasive, that that can happen. If it can be that they are trying to deceive us in some way, so there can be an element of deception. It can be trying to disguise itself, hide itself. There's all sorts of difficult things that you will have to start worrying about and deal with, which makes studying something that is intelligent very hard.
For the old videos, like the one that by military, for example, do you think having a scientific paper it dissecting this video frame by frame? I'm just assuming that the case to get a conclusion. What the possibility would be from scientific point of view?
We analyze it as best we can. Um, Sometimes making assumptions about how accurate or how precise the equipment probably is. Usually you're a little conservative and assume something like 10% precision, which military equipment is probably much better than 10%, so it's a conservative estimate. Um, and we analyze it just to even get a ballpark idea of what could we possibly be seeing here? What could we be dealing with? And so for example, even you can do that with testimony even. Or descriptions. So in the case of the Nimitz encounter, um, Senior Chief Day or Kevin Day, when he was monitoring these Tic Tacs on radar, I mentioned first they would appear at 80,000 feet, and that what they would typically do is drop down to about 28,000 feet, which is a little lower than your passenger jets fly. And then they started heading south along the coast, the California coast toward Mexico at about 100 knots. So what is that? About 120 miles an hour. And periodically he observed them dropping from 28,000 feet to sea level, and that maneuver would take place in about 0.78 seconds, is what he reported. So now you can do a calculation to estimate speeds and accelerations. So how if you're going to go from 28,000 feet to sea level and stop, the of course you can accelerate crazy high speeds and just coast on at a constant high speed and then crazy high acceleration to stop. So you don't know how high their accelerations could be. But at minimum, you know that the minimum acceleration comes from the fact when it accelerates halfway and then decelerates at the same rate the second half. that gives you the minimum acceleration. So you can actually estimate the minimum acceleration. So you can confidently say it was at least accelerating this fast. And if you do that calculation for 28,000-foot drop in 0.78 seconds, it's about 5,000 Gs of acceleration at minimum. And so we know that at least it was going 5,000 Gs of acceleration. Now, nothing we know accelerates at 5,000 Gs. That does not happen. You have a um, yeah. So sorry, yeah, the screen blanked for a minute. Yes, a 5,000 G acceleration does not just happen. That's 5,000 times the acceleration of gravity. Um, People certainly couldn't survive that. People can't survive much more than 10 Gs for any period of time. Even our equipment can't survive that. Like our new F-35 fighters, their wings will rip off at about 13 Gs, 13 and a half Gs. So an airplane can't survive a 5,000 G acceleration. Missiles, which actually have high accelerations, can't survive much. They can't maneuver at accelerations higher than about 35, 40 Gs. And their airframes will collapse at about 60 Gs. And this thing's 5,000 Gs. Very clearly has to be 5,000 Gs. So, oh, could Kevin Dave been wrong? Well, how wrong could he be? I mean, how long would it falling out? How long would the object have to take to get down there for it to be significantly lower? It would have to be a lot of time. He can't be that wrong, and so you can put bounds on things, and that's what we typically try to do with the military data and anecdotal data. We put bounds on things, and so it gives us some idea of what we're dealing with, and it helps when you're trying to decide what equipment to use. If I want to use equipment to capture one of these things on a camera, something accelerating 5,000 Gs, I'm not going to catch that on camera very well. So, what would be the best thing to do? It's probably better to take a long term exposure and get its path than it is to try to get a single frame, which isn't going to work well. And you can actually then use multiple long term exposures at slightly different rates and staggered to get pieces of trajectories. That's a possibility. And so we actually use um, what is observed by others to put bounds on some of these numbers so that we have some idea of what we're dealing with.
Maybe the question I think I want to ask you as a scientist and your team, a question about what is the next thing you try to make this data much better. Like the question maybe you in your mind with the rest of the team, like after writing this paper and what's the next thing. And I think I want to highlight the funding. I think that's the these things I think calls for you. I think the team and how to get the equipment and everything. So I understand it's a
It is a
challenge.
challenge because you need multiple cameras. You need multiple cameras so that you can triangulate positions. So one camera can say that's over this way, the other camera says it was over this way, and then where they cross is where the object actually was. And you need that to be able to get distances. And once you have a distance, then you can figure out size. But cameras only measure angular size. So you need multiple cameras, which is another reason why the Navy videos aren't that great. You need multiple cameras from different angles to learn a lot of a lot of what you want to know about these objects. So what we'd like to do is set up multiple recording stations at multiple locations and have them record for long periods of time and watch areas where UAPs are more common. And now, what we haven't been able to do is get things like spectra. So, just like a prism, when you hold it up to the sunlight, it breaks it into a rainbow. Um, the different chemical elements actually have different colors, and you can use those spectral lines, you call them, to identify what the chemical elements are. So you can figure out what kind of light you're looking at. Are they LED lights like you would expect on a drone? Or are they incandescent bulbs, from a light bulb with a tungsten filament inside that's hot? Or is it a halogen light or a fluorescent light or a sodium lamp, like the lamps that you'll see in parking lots that are kind of yellowish? Sodium has two yellow lines, which is why those lights are yellowish. So you can identify what elements are present in some cases that way. So we would like to get good spectra for some of these things. That would be helpful.
And what does it take to get achieve that? Like, if you say that there's the camera setup that you really, at least maybe
Yeah,
at the stock market, I don't know the technology that exists here.
what you need is you don't really use a prism, but you need something like that. We use what's called a diffraction grating. So they're the place where you've probably seen them is those for Christmas time or something, the holidays where they have like the little cardboard glasses and you put them on and you see like snowflakes everywhere. Anywhere there's a light, there's snowflakes, right? And they're all rainbow coloring. Those are kind of what a diffraction grating. Or if you take a CD and you hold it up to a bright light, you can see the rainbow colors. That's the lines of data of holes on the CD that are stored the data for the songs are actually acting as diffraction grating. So we actually have purchased recently some professional astronomy grade diffraction gratings that go on a camera. So I actually bought that with my own money again because you don't have funding. So I paid $200 of my own money to get a diffraction grating. I paid $150 of my own money to get the software to analyze it. Um, I paid what $4,000 for my Canon R5 camera, which can take light and low, take images in low light conditions. And so now together, and then you need adapters to fit the tiny diffraction grating to your camera lens. Another 45 bucks there, and before you know it, you're out like $5,000 so that I can do this. Yeah, and I paid that out of my own money because we don't have funding. You can't get government funding. Certainly not federal funding, not here now in the U.S.
Do you think because of the government, the disclosure, and it's tied to the situation now, like the grants, like we have NIH, NSF, like this kind of things, but um, how do you anticipate that would take them much to acknowledge there is need for a proper funding? And it's really, to be honest, frustrating and infuriating when I see a lot of money spent left to right for useless things. At least that my I what I perceive. Maybe I'm wrong, but it just there's a need to understand this kind of phenomena. But do you have an idea when do you think the change could happen to have access for proper funding to support these efforts?
Yeah, I don't know when things will change to be able to get funding. The right now different UAP groups depend on funding from individuals, right? Individuals make donations. So I think that the Galileo project was able to get a couple $1 million to do their work, which was very nice. Um, we've not been so lucky at UAPX, and so a lot of the equipment that we have, we bought with our own money. So like I just said, $5,000 for my nice camera, and now I use my camera for shooting wildlife and other things, which is my hobby. So that's not totally for UAP work, but the diffraction grading is, and I also have two FLIR cameras that I own. I got those on eBay for about $4,000. Um, and but they're used and they're one of them's not that great in condition, so it's not the best equipment in the world. Can I measure temperatures? Yes, with it. Yes, I can. And so I will use it. I'll use anything I can get my hands on to collect data at this point. And that's basically where a lot of the UAP groups are.
I hope the coming weeks or months bring better tidings for you and the group to do more and
Thank you. Yeah, I hope so. I mean, to get a nice to get an array of equipment that we would really want to be able to collect the data we need would probably be around ten to $20,000 for one collection of all the equipment you need. And then if you want to have multiple recording sites, then you multiply that times how many recording sites you have. So if you need at least two for triangulation, better to have three. So you're already looking at something like $30,000 to $60,000 of equipment, and so it adds up. Yeah, it adds up. But it'll also allow you to tell whether you're looking at ball lightning or a seagull or an something that a highly advanced technological craft. You could tell the difference with that equipment. So
Yeah, I'm very confident. I'm hopeful also with the work you're putting and rest of your team also. I think you will get much better soon. I'm hopeful for that. Um,
thank you.
yeah. So the maybe Santa Claus then a few question. Maybe I asked this question I think multiple time, but and also we have Gary Nolan actually next week. He will also be in the podcast. I'll ask you if you have any question for him or something. Ray Marcus, out of curiosity, I don't know. You already talked with him, but I'm curious what kind of remarks you have for him or questions also. But before that, studying that and observing that from um, yeah belief system and look into our universe, it seems crazy when we see human fighting each other. Just a bit of stupidity there. But when you look to what you have been studying, and do you sometimes question your belief system and how everything's set up in our life? If it's proven there's something, it's frustrating. We don't know exactly what it is, and it's yeah, it's mystery. It could be mystery. I hope we can know what it is. But how that it change shaped you, change your belief.
Well, I mean, a lot of it is still up in the air because we really don't know what we're dealing with in a lot of these cases. If we have, when you see that some of these things appear to be highly advanced craft, then that it would have to be non-human. So now you've got another. It suggests that we very possibly share this planet in some sense with another intelligent race that we don't know anything about. So this is that's rather sobering. Um, we don't know what the situation is. We don't know who they are. We don't know what they're doing here. We don't know what they want. Um, and so this really should be. I mean, I think people are overloaded with concerns at this point. And this is probably one of the biggest ones if you were to actually sit and think about it for some time. But I don't think people have the bandwidth to be able to think about all of these things. So it's hard. So now, how does that change your worldview? Well, we live on a tiny little planet going around an average star in a giant galaxy with 300 billion suns. Who else is out there? What else is out there? We actually don't have a clue. We don't have any idea of what's out there. Um, and the whole galaxy could be teeming with life, and you could have intelligent life all over the place. It could be like Star Trek out there, and we wouldn't know. And so that's a very interesting situation, right?
Do you think why of that? Like when you think deeply about the reason for that, from your perspective or understand, how do you see that setup was for? Like because you speak in the paper, it's not only scientific, it's also societal, spiritual. And I'm also curious if you expand how to get more funding, you need more people. Like it's not only about science, but spiritual and how to understand these things if it's really intelligent and know they observe it and they don't want to be observed for whatever reason that we don't know. But how do you see this was designed for? If it meant that we are very limited, and do you question this in regular basis, like why, or it's just accept it as this? We are here, human for
Oh yeah, no, I question as to why, and there's a lot to wonder about at this point. So one thing I have done is, we've all of us scientists who've looked at this problem and have been confronted with the possibility that there may be non-humans involved in some of these cases, then we've all thought about, well, what does that look like? What would they be like? What would the situation be? So one of the papers that I wrote recently, and I published this in a proceedings volume. I presented it at an astronomy meeting in England last year, and the astronomy meeting was focused on searching for life elsewhere and what do we think it might be like? And so when you're confronted with the idea that maybe you've got non-humans coming to Earth, is that really possible? Can you really per- perform interstellar travel that way? What would you have to be able to do to be able to get to Earth? What would your technology have to be like? And so these are, questions. So you can sit and wonder about this, and it doesn't really help you come up with numbers or anything, which is what the scientists would like. So what I did is I simulated um, societies actually performing colonization from star system in the galaxy. And I simulated about 2 million civilizations. I gave them very simple set of parameters to mostly describe their abilities for space travel. And how do you simulate a civilization like that? You just choose those numbers randomly and see what happens, right? And I did that 2 million times. And you find first that it is very hard to find Earth. That is really the it's not a big surprise. It's a big galaxy with 300 billion stars. There's a lot of places to look. It takes a long time to find Earth. I'm actually going to open my that paper because have real numbers there that I just can't. I don't store numbers in my head. I write them down so I don't have to store them. That's the whole point of writing things down. Yeah, I use my brain to think, not to remember things. Um, that's what I tell people anyway. And here, this is what I want. Yeah, so when you actually work out these numbers, and this paper you can find on my website as well. I have links to it. Um, the Yeah, I found that only about 22% of spacefaring civilizations were capable of interstellar travel. One out of five of them could make it to another star system. Um, but then finding Earth is a much lower probability. So in all, if you have a spacefaring civilization somewhere in the galaxy, the chance that they could find Earth is 0.00009%. So it's about point decimal point and then three zeros 1% basically. So the chance of finding Earth is very small. It's hard to do. Um, but then you can start. So that's why I ran 2 million civilizations. I did it 2 million times, and I collected all of the civilizations that found Earth in my simulations, and then I made histograms of their capabilities because I wanted to see what are these guys like. What would you need to do to be able to find Earth? And or what would your qualities be like? And so one of the surprising things that I found, first, you don't have to go faster than the speed of light. You don't even need to go more than 30% the speed of light. 30% the speed of light makes it possible. And that's something we might be able to pull off at this point if we tried. Um, so So what I did find though is that they have, on average, after basically they're colonizing areas of the galaxy. So on average, the radius of their domain is something like 500 light years on average. So they go a long distance, and the average distance to Earth from their home world is on the order of about 500 light years. So the uncertainty of that is actually quite high. It's 500 plus or minus 400 light years. So you don't really, that's an average. Um, but what I found was really the most shocking was that then what is the average, how long, if you find somebody is here now, you can then calculate when they first discovered Earth on average. And the answer on average comes out to be about 1 million years ago. So if there are non-humans here on Earth that came from somewhere else, colonizing their galaxy in this way, they probably found Earth 1 million years ago, which means they've been here the whole time, which which is in agreement with sightings. I mean, you have sightings going back to the Roman times. There are ancient Chinese, Japanese sightings. There are, um, and those are of discs, very similar, or flying earthenware or flying umbrellas. If you're in Japan, um, they describe the same things. So they've been here a long time. But then you have to start wondering that their domain covers 500 light year radius. Does Earth sit in their domain? It could it could very well be that they believe they own Earth because they found it, right? So we might actually be owned by somebody. And not only is Earth owned by them, Alpha Centauri is owned by them too. All the nearby star systems, everywhere we might want to go someday, they might actually already own. And so now what does that mean? I mean, what is it? So
I'm struggling with this because, like, when we see the human Neanderthal, I think that's Neanderthals before Homo sapiens. And I'm not sure how this will shift all the historical evidence of how human, like us Homo sapien, developed. How all is true, I'm not sure. And if it's really they own the, like, if they living in the bottom of ocean or in the mountains, why they accepted us and not showing, reveal themselves to us, like, this kind of thing is just, why you do, if I own something, why I hide, like, it doesn't settle with me.
those are all great questions, and it gets to be hard because now you have to start to worry about intention, right? And what are the motivations? What are their intentions? And you're talking about non-humans, so it's very hard to figure out. I mean, what are the intentions of an anthill? Do you know? I don't know what anthills intend to do. I have no idea. I don't study them either, so that doesn't help. But so we're talking about another race of beings that are intelligent, and we don't know what their intentions are. So it's very hard to speculate why in these situations. Um, and so that puts us at a huge disadvantage, right? Um, so of course there are people who've thought, oh, they've influenced human evolution. Well, if they've been here a million years, they very well could have. I mean, but maybe they didn't care either. Um, and so it could very well be that um, they just have some science monitoring stations on Earth, and they just keep track of what's going on Earth because they're interested in the science of it. There's a lot you can learn from biology. We learn from stuff from biology all the time. And especially if our biology is different than their biology, then this is a whole different biochemistry for them to learn about. So there's plenty to study. Um, so it could be just scientific observation locations. Um, and then, of course, the game kind of changes in World War II when humans started flying. We started making machines that are closer to what they have, right? Now, well, what are these guys going to do? And these humans are rather violent. They're killing each other left and right, especially World War II. And then we have nuclear weapons, and so it could be that so you could easily imagine that if if they consider this to be their planet, then in the last 100 years, humans have evolved to the point where we are able to destroy the planet, right? We think of it, we're able to destroy our planet, but they might have a different perspective. These humans may have the ability to destroy our planet, right? They're like, wait a minute, now all of a sudden we're at odds with them, right? And in fact, when we do encounter them with our fighter jets, we shoot at them. I mean, that's been going on for decades. There are many cases like this. So it could very well be that we became a problem in the last 100 years.
True, and I think one of the point I think I'm struggling with, I think it's come down to intelligence. It's all about intelligence, and it seems life it's about natural selection, survival for the strongest, whatever. It's true. I think that's what happening, and when I see what happening in Silicon Valley, especially in super intelligent AI or artificial general intelligence, and seems some people like I don't know. I don't want to say oligarchy. Or they dominate everything. It seems they set the narrative for all of us where the next thing should be, and it's quite scary because I'm also trying to think about if you're having a machine, not a robot. It's just the intelligence. It's not biological intelligence. It's artificial, but we are able to get all this, yeah, data and getting to somehow intelligent machine that can outperform most of us. So I think that's quite a scary thing because I'm not sure if we're going so fast for, yeah, monetary benefits, whatever. But it seems unsettling, at least for me. Maybe I'm wrong that if you have most of the human, for whatever reason, not intelligent enough, and you have intelligent machine. So how this will it shape everything in this? Yeah, I'm not sure. Are you afraid about that? Are you? Do you think there's different outcomes?
It's hard to know. I think humans, I think we're always our own worst enemy. So I think that's the bigger problem. Um, I don't see them as anybody to worry about. People often say things like, "Well, if they wanted to take over Earth, they would have done it already." They took over Earth a million years ago, according to my simulations. So we missed we missed first contact, and we missed the Earth being taken over. I mean, we missed it. We came after. That's a whole different perspective, right? So are we in conflict with them in some sense? We might end up being, and things that might mean that the game changes. And we have observed that their interactions with the military, our human military, has changed. They've become more aggressive, and in fact, that was written up in congressional, um, one of the congressional documents. Actually, noted that they have become, and he used the word exponentially, which he's not a scientist, so he's using it wrong. He means a lot. But they said that they have become exponentially more aggressive toward our airplanes. So I don't know exactly what that means, but they, but I do remember talking to Luis Elizondo and others and learning that was it 2015 when they were having near daily encounters. U.S. Navy was having near daily encounters with these objects. Uh, we were we had I think the USS Roosevelt was in the Persian Gulf and they were doing bombing runs into Syria, and on the way up, flying through north through the Persian Gulf, these objects would fly at the airplanes. They would fly at our airplanes and they would dodge just the last minute, and it would panic the pilots. So it was bad for the Navy because these pilots are panicked having encountered these objects that are freaking them out before they're entering a war zone where it's actually dangerous. So it was a very bad situation for the Navy, and that actually is what led to the Navy going to Congress and saying we need to do something about this. That's actually what happened. And in one case, I heard that the one of these objects flew at the airplane and did barrel rolls around the cockpit and then flew off. So that's pretty aggressive, without shooting at it, right? So they're not shooting at us, thank God, but they're not avoiding us either. So it's a strange situation, and it's hard to interpret what that means. And especially because we don't know who they are, we don't know where they're from, we don't know what they want, we don't know anything. So this state of ignorance that we're in is really completely unacceptable. I mean, you can't be ignorant about something like this and expect things to go well. Something is going to go bad at some point, and so we scientists are trying to study these things. But it would be nice to get, some kind of federal support, for funding, or at least have the federal government open up as to what they know about these things so that some of us can learn more. I think that's important. And I think that's part of the problem with disclosure. I don't think they know what to disclose. I don't think they really know. I think they know bits and pieces. I think they know a few little things, but they don't really know what the big picture is. And so disclosure doesn't really work because we're going to have so many questions that they won't be able to answer. So what's the point? I think that's the real problem.
I agree with you. I think makes a lot of things. And I appreciate your time. I know you have to have a lot of things to do, but maybe the final thing. Anyway, we would love to hear from you the next expedition and the update. I know you have been working hard to get where we are now. But yeah, maybe for Gary Nolan, do you have any comments for him? He will be in the podcast next week. So I'm not sure if you have any comments for him or anything you think could be interesting to share with him if you would love to.
Oh, say hi first. Hello, Gary. Um, no, it's interesting. He's doing work on materials analysis, which I think is great, and interesting. And I think all together we're going to keep learning things. I mean, we're attacking the problem from multiple angles, and scientists are talking to each other, and we're putting pieces together. It's slow, but it's happening, which is good.
A last thing I know that Lockheed Martin. Do you believe that they know the full picture? Lockheed Martin, the company, aerospace company. Do you believe they have some full picture of this information? Lockheed.
No, no, they might have a craft or something, but they probably don't know how most of it works, and they probably don't know. Even if you have a craft and bodies, you still don't know where they're from, and you don't know what they're doing here, and you don't know what their intentions are. See, so the big questions that you really need to know, you aren't going to have any info on. I think that we're I think that the best thing to do is to have everybody work together on this problem and try to figure it out. You need a lot of brains on this problem because just two people working on it isn't going to be enough.
100%. Do you have any final words for UFU community or people, yeah, listening to anything you would like to
No,
say?
read our papers. Actually, read our papers. There's a lot to learn there. I learned a lot writing it. Um, Absolutely fascinating work's been done. Astronomers have seen these things. And scientists have seen them. In fact, the scientists working at Los Alamos in 1952 actually formed groups and started shifts watching for UFOs because there were that many sightings around Los Alamos. The scientists were actually, and they had diffraction gratings and cameras just like I have to try to get spectra. They were doing everything back then what we're trying to do now, but they were not organized. They were just doing it on their own. It's fascinating.
Again, it was absolute pleasure to talk to you again, and it's always fascinating to listen to you and talk to you. And I wish you great success and
Thank you. Thank you so much for having me.